So a few years ago, we actually got a large amount of data from a major commercial bank in the United States, credit card data. It turns out that they were losing something like $15 million a day in their credit card unit because of defaults and delinquencies. This was during the financial crisis and the aftermath, 2008, 2009, 2010. And so they asked us whether we would be willing to apply some of our techniques to their data because they knew that we were working on machine learning applications. So they gave us a lot of data on their consumer credit card accounts. They gave not only the usual credit bureau data of your income, your employment, your mortgage, but they also gave us credit card transactions, so restaurant receipts and so on. And then they also gave us banking information like ATM transactions. We integrated all of this data, and back in 2009, this was about 10 terabytes, which was pretty hard to manage. Excel will not handle 10 terabytes of data. You can't use the traditional tools. So we started looking at the data, and we put together features, characteristics of the data to try to see whether we can come up with predictive power. And so let me give you an example of a feature that we came up with. So we looked at consumers and tried to calculate what their income was every month. And we looked at whether or not these consumers had any kind of interruption in their direct deposits. So if they were getting direct deposits regularly for the last couple of years, but within the last 3 months, their direct deposits stopped, we would put a flag of 1 on those consumers. And if you do that, let me show you what you get. So these are the delinquency rates of credit card customers for the entire bank. And the red line are the delinquencies of consumers that had their direct deposits stop sometime in the last 3 months. Now, this shouldn't really shock you, because if you had a direct deposit for the last 2 years and it stopped in the last 3 months, most likely you got fired, and as a result, you are going to be delinquent in your credit card. By itself, this feature wasn't particularly predictive, but when you combine it with 100 other features like it, and you use this technique called machine learning to come up with the appropriate way of categorizing customers as deadbeats or really good credits, it turns out that it works remarkably well. So the techniques I won't have time to go through, but they're sort of like tree diagrams, one set of techniques where it's also like k-means classification. If you think about the classification as a good credit, that's your good dot, and a bad credit, your bad dot, you have to come up with characteristics to compute those dots. And then you use k-means to split the sample into those two. Well, this is sort of how it works with the various techniques that we use. We want to split up the space of features into good credits versus bad credits. And let me show you the results, and then we'll move on. So we wrote the paper and published it in 2010. The sample that we had were 600,000 customers per month, which is a 1% sample of their data. So this is like a big company. And it took us at the time 40 hours to run the model once, 40 hours. We actually did a quick back of the envelope to see what would it take today. If you did it today, it would take about 10 minutes. So, Moore's law, right? So let me show you the results. So this are the results. I have to explain to you how to interpret it. Each dot here is a different customer account. And the location of the dot represents 2 different scores. The horizontal score is the credit score that you would get from a credit bureau, like a FICO score. So that would tell you from the bank's current perspective how they are looking at the credits. The higher the score, the better the credit, the less likely the bank feels they're going to default or be delinquent on their credit card. Okay? So this customer would be considered by the bank a very good customer. On the y-axis is our score, where we're predicting the probability of a delinquency or default. And so from our perspective, the higher you are, the more likely it is that you're going to default. You're a bad customer from our perspective. Okay? So the reason we plot these together is we want to see what the relationship is between the bank's method and our method. And if you look at this, there's no relationship, right? It looks random. If there were a strong relationship, you would expect like a negative sloping line, right? Because we're predicting high probability of the low scores and low probability of default for the high scores. But you don't see any real relationship. So this is the predictions that we came up with in 2008, fourth quarter. Now let me show you, after the fact, what actually happened using color. I'm going to change this graph to a graph that's color-coded, where green is going to mean customers did not default or were not delinquent in the next 90 days. And yellow will mean that they were actually 30 days late. Let me show you. Sorry, blue is 30 days late, yellow is 60 days late, red is 90 days late. So what you see is something really interesting. If you were the bank and using the FICO score, you would draw a vertical line and say everybody to the left of the line doesn't get credit, everybody to the right of the line gets credit. And that's actually what the bank did. I'm not going to mention the bank, but I suspect you know the bank, because if you were part of the bank, if you had a credit card from the bank, sometime in 2008 or 2009, you got your credit limit cut by half. What they did was they went through and cut everybody's credit limit by 50%. They cut the CFO's credit limit by 50%. Everybody got cut. So what they did was they said, you know, here's the credit score, everybody gets cut. And what you see is that there are a whole bunch of greens. These are people that are not delinquent. They paid on time, and you just cut their credit score and you really annoyed them. They're likely to leave the bank now and get a credit card from somebody else. If instead you used machine learning, that would mean drawing a horizontal line. And if you did that, you notice that you get rid of the red and you keep the green. It makes a lot more sense. It's more accurate. Now, this is not to criticize the bank. FICO scores are not meant to be used as credit card prediction methods from month to month. The FICO scores don't change, you know, year to year, never mind month to month. So, but it does say that what we typically think of as consumer credit is very different when we have the ability to use these machine learning methods to predict. So these are just statistics to show you the predictions are actually quite good. And in a paper that we published last year, we were contacted by the US Treasury after they read the paper, because they said, you know, they asked us if you'd like to try these methods out on not just one bank, but on 6 of the largest banks. So they said, fantastic, we'd love to. Can you give us the data? They said, no. But you can come down to DC and you can use our data on our servers, on our site, with our researchers. And so we did that. We published a paper with these colleagues from the Office of the Comptroller of the Currency, part of the US Treasury, and we applied it to 6 of the largest banks, 25 terabytes of data, and what we found was that there was a lot of differences among those 6 banks. And we actually showed that certain banks are really good at cutting the credit of consumers that are likely to default. They actually, almost as if they were using our model to do that, whereas other banks were clueless. And this now allowed the OCC to focus on various different banks for risk management purposes and oversight. And so this shows you the features. We have a bunch of different features, and the red means features were selected for the model that we estimated for the banks. And different features get selected by different banks because they have different customers, different practices, different sensitivities.